First of all, what are tables here? Right. So let us see here. See, the tables means here not those tables. What exactly we are actually till now we are making in the SAS. See, the tables what we are making in the SAS is automatically. For example, whenever you are taking any data from external file or the internal program, it will convert first into table. Right or wrong? That is one of the thing which is happening in the SAS. So always the tables are by default created. So that is not the making the tables. That is very simple. For example, by using data, by using the data step, right? If you put data, if you put name of the table, if you write, if you import the file or you can do anything, directly you can make the table. That is very easy actually in the SAS. But these tables, what is mentioned here is not that tables. Understood? These are the special tables. These are the special tables actually we are making in the SAS. So that tables are nothing but here the mock shells. Understood? MOCK mock shells. So how these tables are made and what is the importance of these tables? You will see here. This is very important actually topic, right? First of all, one document is there in the SAS. What do you call that one as a SAP statistical analysis plan? Here, this is a SAP document. See, SAP document is nothing but the detailed document which is actually supplied to the programmers. This will show the actually the detailed step-by-step process or detail actually the instructions to the programmer, what type of tables, what type of actually results we want. We means the clinical trial industry or the sponsor or the higher authorities, whoever are there, what they are actually expecting from the programmer. That details are mentioned in this document, Statistical Analysis Plan SAP. The full form is Statistical Analysis Plan. See, in these, some of the tables are given. One of the actually here, this is a real-time project actually where we are having the demographic. This is a research carried out actually on the people. So this one of the actually I have the file here, right? So in this, the double-blinded studies are there, right? In which 60 subjects are taken, right, into here. And finally, what exactly we are using is nothing but, so we are using the anesthetic. Anesthetic means here, what you know anesthetic, right? So anesthetic means what here? Which is actually used to induce what here? To induce the, what we can say here, anesthesia. So to make the unconscious, to make the patient unconscious, usually this anesthesia is given for performing what here? Surgical procedure. For performing surgery, for performing surgical procedures, we are using these anesthetics. Clear? So these here, for example, spinal anesthesia is there. You know spinal anesthesia? Spinal anesthesia nowadays, there is no general anesthesia. General anesthesia and spinal anesthesia, what is the different? General anesthesia means completely we are making the person unconscious. But nowadays, spinal anesthesia is given. So in the vertebral column, backbone, we are injecting something with which the patient will become, the lower part or some of the part will become means he will not feel. He will not feel, right? The surgery is usually nowadays spinal anesthesia is used. See, along with the spinal anesthesia, right? So one more actually, if subject is given, one more actually drug, what we can say, magnesium sulfate and fentanyl. So fentanyl actually, these two are given along with the spinal anesthesia. Adjuvant means along with the spinal anesthesia, and for this is given for what purpose? For post-operative, to block the pain. Understood? During surgeries, to block the pain during surgeries. So this is how the finally the background I am explaining you about this file. What this file consisting of? 3 groups are there. Let us see, 3 groups are there here. Double-blinded study is there. In these 3 groups, see, one of the group is group F, which is actually getting what here? They are getting the bupivacaine, right? So bupivacaine and fentanyl and normal saline. So this bupivacaine is nothing but here main spinal anesthesia. The spinal anesthesia medication is mainly bupivacaine. See, along with the bupivacaine, extra drug received is nothing but the fentanyl. Here fentanyl is one of the drug. Understood? So that's why we are mentioning group F. F represents what here? F means fentanyl. Understood? F is a fentanyl here, the name of the drug. So in the next part, what we are doing here, second group is getting the spinal anesthesia plus, along with this, what they are getting? They are getting magnesium sulfate as the extra medication. That's why we are mentioning group M50. 50 is represent what? The strength of the magnesium sulfate is 50 milligram. Everyone clear? Now third group is there. Third group is receiving the spinal anesthesia plus fentanyl also and magnesium sulfate also. Everyone clear? What are three groups here? First group is what here? Group F. Receiving what here? Receiving just fentanyl along with the spinal anesthesia bupivacaine. They are receiving fentanyl only. That's why the name is what here? Group F. Only fentanyl with the spinal anesthesia. Second group is what here? Magnesium sulfate 50 milligram along with the spinal anesthesia, group M50. Third is what? Receiving fentanyl also and what? Magnesium sulfate also, both. That's why F plus M50. Clear everyone? F represents fentanyl, M50 what here? Represents the both it is receiving. So these three groups are formed here in the study. So these three groups, now it is clear now everyone. So the basic characteristics of all these group, the baseline values, you know the baseline values means what? The blood pressure, SBP, DBP, right? The pulse rate, so many things. They are taken actually, they are measured, right? For this group, and it is stored in a separate file. I have one file. Can you see this file? SCNM13. Understood? This is SCNM13 is a code actually for this file. So don't bother about the name of the file. But this file consisting of what here? The detailed information of the patient, right? Their vitals. Vitals means what here? All the basic information, baseline information. Like for example, we are having the heart rate, right? Blood pressure, heart rate, right? And we have other so many values also there, right? Like, so these are not required and you should not concentrate. We want exactly what the basic information, this all information is there and the information is taken like B5, 10, 15, 20. So every 5, 10, 15, 20 minutes. Getting me? See, we are taking the value after 5 minutes, then after 10 minutes, right? Then after 15 minutes, then after 20 minutes. Getting me? The heart rate after 5 minutes, 10 minutes, 15 minutes, 20 minutes. Blood pressure, SBP 5 minutes, 10 minutes, 15 minutes, 20 minutes, right? So because the values we are actually measuring every what? Every 5 minutes later, the values are measured, the monitored. Because during operation, what they will do for the patient? They will monitor the vitals. Why they will monitor the vitals? Because the vitals are getting disturbed, the patient may die. Are you getting me? So the vitals has to be monitored during surgery. Yes or no? You have to monitor the surgery. Anyone from the medical background, they will understand what I am telling here. They are closely monitoring the vitals. So this is that actually file. Everyone clear? And this is the original file where the readings are taken directly from that. Understood? So this actually now the question arises, what we are going to do. Now the basic, the information, the background I have explained you in detail. Now coming to our intention with the tables, what exactly we want. See here the sponsor or whatever the project team or whoever the higher authorities, they want the mock shells. They are in this pattern. Now the question is, what is this table exactly? Is it looking like a normal table? Is it looking like a normal table or no? It's not a normal table. It's not a normal table. Here the information is combined, right? And the summary is drawn from the information. The summary, it is not like a normal information. It's a summary from various places. We gathered the information at one place. Are you getting what I'm telling? Here what happened? We gathered the information, right? From various tables into one table. See, what is this information consisting of? If you see here clearly, the first row, what is the first row here? It consisting of gender. Gender M by F means what? M means male, F means female. Understood? And N by N means count. N by N means, what is the meaning of N by N? Count. See, number of males slash number of females. Getting me? In the numerator, what we have here? What is the numerator? Number of count of males. In the denominator, number of count of females. So male by female. Understood? By means we are not dividing, just male by female we are writing the values. For example, 10 by 15. 10 by 15 means 10 males, 15 females. Like that we want the final report in this format. And here we have the 3 more columns: group F, group M50, group F plus M50. In group F, what is having here? X by XX. See, what is the meaning of X? I told you, 2-digit number, right? Maximum divided by 2-digit number. So not more than 2-digit number actually here, right? And there should not be any decimal. XX by XX means any decimal point is there? No decimal point. 5 by 10. 5 by 10 is the example of XX by XX where there is no decimal point. So in this way, we want the number of males and females in the group F. Are you getting me? See, this is total. This is what here N by N means? Total. Sorry, this is actually the representation, not total. This is the representation N by N, male by female. And here group F means number of males, number of females in group F. Clear? And here group M50 means number of males and number of females in group M50. Here group F plus M50 means number of males and females in group F plus M50. Clear now, everyone? What does it mean? Okay. Now yes, here sir. One more capital N is there. What is the capital N means? Total number of subjects. Total number. Capital N means total number. And here small n means what here? In this bracket, small n means number of subjects in group F. What is n here? Small n here value. XX means what here? For example, take XX value as 21. So n is equal to 21. N is equal to 21. This 21 is what? Number of people in group F. And here n is equal to XX means here number of people in group M50. Here n is equal to XX again means what? Number of people in group F plus M50. Getting me? Number of people in group F, number of people in group M50, number of people in group F plus M50. These n represent that values. Everyone clear? First row is over. Now getting the second row. See, second row we want n%. What do you mean by n%? See, there are 2 terms here. First term is n, and in the bracket what we have here? Percent. Everyone clear? See, what do you mean by n this? N represent again count. N represent what here? Count. Count means which count? Frequency count, number of people. Understood? N represents what here? Count. See, what is the bracket inside represents? Percentage. Are you getting me? The bracket represents what here? Percentage. For example, the count is how much? Let us consider we have taken just an example is 21. Count is how much here? 21. Just so I told you 21 for the group F example, right? 21. And the percentage of that value. See, 21 in terms of percentage, for example, the values are something like a 70, 80 values are there. So the percentage coming 33% something. Are you getting me? Value coming how much? 33%. Everyone listening me? See, first of all, there are 2 values here in this. One is the n is nothing but the count, right? And percent means how much percentage that values attributing, or how much it is actually the percentage it is making for that value. So n is 21 means 21 is how many percent? 33% for example, or 33.5%. or 30%, whatever. Just I'm giving the example. It's not the real value, just for explanation. So 2 values are there. One is outside the bracket. Outside the bracket is what here? It's a Whole number. Whole number means without any decimal point. But inside the bracket, what we have? Can you see here? Inside the bracket, xx point x means what? Xx point x means what? Here the decimal point also present. For example, 21.3 or 33.5. Getting me? Xx point x means 33.5. Example. So that is actually what? Xx point x format. Clear? So two values are there. One value is the count, other value is the percentage. Percentage is enclosed within the what? One more thing. Percentage enclosed within the bracket. Within the bracket. Now clear everyone? See, next is what? Mean plus or minus SG means the first value is a mean in between plus or minus. Second value is a standard deviation. Getting me? Mean plus or minus SG means the first value is a mean plus or minus in between. The second value is a standard deviation. And here also, what is the format here? Xx point x means they should be decimal or not. They should be a decimal point, and after decimal, how many digits should be there? Only one digit after decimal. For example, whatever 15.1, right? 12.5, like that. One digit after decimal. Everyone clear? Okay, next row is median. Understood? And next row is what here? CL actually. CL of mean means what? Class limits. What is the class limits? See, anyone you studied the statistics, right? In the SSC or if the pharmacy background are there, they have the biostatistics one subject is there, right? See, actually, class limit means there is a class interval. For example, if you are arranging the in the statistical values in the form of classes, for example, 5 to 10, 10 to 15, 15 to 20. Have you just noticed this point in the class interval? They are calling it as a class interval. Understood? Frequency class interval. One table is there. In that table, the values are arranged in the form of groups. These group, for example, 5 to 10, 10 to 15, 15 to 20. So these values, see, 5 to 10 means the 5 will be called as what here? Lower class limit or lower boundary. What do you call that 5? What do you call that 5 value? It is a lower class limit or lower boundary. And that 10 represents what here? Upper class limit or upper boundary. Everyone getting me? Now you understood what is the meaning of lower class limit. CL means what? CL means class limit here. It's not I, it is L actually, right? CL means what here? Class limit. They are given CI or anyhow. So here it should be class limit. So what are the class limits here? First value represents what here? Lower limit. Understood? For example, in our case, what I have taken just for example, 5 to 10 means what is the lower limit here? 5. And what is the upper limit? For example, 10. Understood? So 5 comma 10 here, but we want the value in the bracket again. And what is the format here? Xx point x means after decimal. What we want here again? How many digits? One digit. One digit after decimal represents the lower class limit and upper class limit. See, what is again? Now next one more value is there. Range. See, range means what here? Range is the minimum and maximum values. Understood? Range means minimum and maximum values. Minimum comma maximum. Again, this minimum and maximum should be enclosed within the what? Within the bracket. The first value is the minimum. The second value is the maximum. And here the first value in the previous line. First value is what here? Lower class limit. Right? And the right value is what here after comma? There is a comma in between. It's very small, I think. The font, I don't know whether it is visible or not. The first value is the lower class limit. And the next value is between comma is there. After comma, second value is the upper class limit. See, we want this table. Can we draw this table normally by using the proc step or data step? Is it possible? Is it possible directly to draw this table in a one step by using any data step or proc step? This is known as mock shell. What do you call this one? MOCK mock shell. For this special programming is there. So that is nothing but the tables. So here first of all we'll try to make this table. I have given the introduction. So much time is gone in the introduction, but this is required, right? Without this, you will not understand what I am teaching you. So suddenly, if I teach all these things, everything will go over the head. So I have just given the basic description. Now we are starting the real programming part. See, we want to get this programming. We can divide the whole program into two parts. See, this is the first part. Can you see everyone? I have selected the first part, which is containing the gender statistics. What is consisting of? Gender statistics. And the second part is consisting of what? Consisting of age statistics. Everyone clear? What we are doing here? Dividing the program into two parts. First is what here? Gender statistics, which is dealing with the statistics of the gender. Second part is what here? Age statistics, right? Which is dealing with the statistics of the age. Now we are deriving these two separately. Then we are combining these two. Like merging, not merging, concatenation. Everyone listening carefully, yes or no? What we are doing here? We are deriving the statistics separately, the gender statistics separately, the age statistics separately. Then both we are joining. Both we are joining by concatenation. So this is our intention. So these two statistics we want, gender statistics and age statistics. So now first of all, we are deriving the gender statistics. See, for deriving the gender statistics, now we are doing the programming part. Listen carefully. See here, we are importing that file. Which file we have now here? SCNM13. That is actually I told you which is having all the details of the baseline values, right? So first of all, we are importing this file. Understood? So you know the proc import, how to import the file. I am not explaining. And here the sheet name is complete. Only one sheet is there. How many sheets are there inside? Excel file, only single sheet is there. So that we are importing this file first of all into the SAS environment. This is a very simple, right? So now we are running the proc import to import the file. See, we imported the file into the SAS. See, but here in this program there are so many variables. Almost how many variables are there here? Total columns how many? 42 variables are there. 42 variables are there. See, but in our statistical, whatever we want to do in the mock shell, only how many variables are mentioned here? We want the gender, one variable, right?
Age.
Second, age, and the group. Here, group variable is also there, right? Group we are dividing into three types. 3-4 variables are there maximum. We don't have much variables. But here, how many variables are there? Almost 42 variables. We don't want this many variables for our statistical, what we want to do for our mock shell, right? The table we want to derive, we don't want. So what we are doing here? First of all, we are keeping only 4 variables. What are the 4 variables here? Patient information, group information, age, and sex. These 4 variables only we are keeping. Other variables we are dropping. Other variables, what we are doing? We are dropping. Now you can see the table. How many variables are left out? Only from 42? Only 4 variables are left out. We want this many variables only. We don't want this the lot of 42 variables. Now we are going to work on these 4 variables only. See, first part I told you in these, we can divide into 2 parts. See, the first part we are doing the gender statistics. See, what type of statistics is this? Just see here. N means what? What is N? N means frequency count. Frequency count. See, frequency count means N. See, where we are getting the frequency count? Anyone? Which procedure is measuring the frequency? Proc-freq is there. So that's why we are doing proc-freq. First, we are doing what? Proc-freq on which variable exactly here? Here, if you see clearly, see the variable is here sex, but again we have the we want actually the value actually for the sex. In short, we can say the proc-freq value we want to derive for the sex. Understood? This is clearly mentioned. Gender means what here? Gender is nothing but gender is the sex only. But one more thing, we want to group the values by groups. See, we are having the gender statistics, but separately for group F, group M50 and group F plus M50. So I mean to say that here we want the cross tabulation. Cross tabulation means group versus gender. We want the statistics in the frequency. What versus what? Gender versus group. See here, the group is present in not in separate columns. If you see the table, the group, all the groups are present in a GM50, GFM50, all are present in a single column. What is the name of that column here? Only group.
Group.
See, there is no GM50, GF50, like separate groups. Are, now in the file we don't have, but we want separately, that we will do later on. But here we have the group and we have the sex. So these two information we want to draw the table. Which table? First group and sex. We want to combinely, we want the table. So that is the cross tabulation. What do you call that table? Cross tabulation. See, cross tabulation, how to draw, I told you in the proc freak. Just go and refer. Group star sex. What it will do? Group star sex. It will draw the cross tabulation between the two variables, group versus sex. Everyone clear? Group versus sex. It will draw the cross tabulation. Now we are running this program. Right? Output table is DM2. We are drawing the frequency table, group versus sex. Can you see everyone the result? Okay, this is the result here, right? We got the result. So finally, okay, this is important, the count. Can you see the count values here? 3 for the female, right? 18 for the males. Getting me? Here. See, we got the counts for the female separately and males separately here. Understood? So this is how we have actually taken the group. So group versus sex, then finally the count values. Group versus sex, the count value. We got it or not? But this is not in the, see the output table. See, is it looking in the pattern which is there in the mock shell? Mock shell, we want like this the values, or we want the values in another pattern. See, the pattern is same here and here matching. Is it matching? It's not matching. It's not matching. See here the count is, for example, present separately for female here, right? Okay, male here 18. So we don't want the count separately. We want M by F value. What we want here? M by F value. But this is a simple table showing the count of females and males separately. It's not in M by F format, right or wrong? So that means it is still not matching. And one more thing here. See here actually we want actually the by group actually, right? So we want to, what exactly I mean to say is that we want to actually reshape the data. What we want here? We want to reshape the data to bring it in a structure which is as per the mock shell. See, still our data, whatever we got, it is not as per the mock shell. Everyone getting what I mean to say? We got the information, but this information is not sufficient. This is not as per the mock shell. Everyone getting me? So to get this information as per the mock shell, we are again modifying. See what we want as per the mock shell. Just go and check. We want M by F. We want M by F. See what is the meaning of M by F? Male by female.
Female.
See, male count by female count. See how to get the male count by female count. Now question arises. See how we will get the male count by female count. See, we have the count in these. All are clubbed together in one column or separate column count? One column only. But there we want male by female separately. So to divide male by female separately, first we want two values. See, for example, I want, for example, take 20 by 3, or take any value, 10 by 3. See, if I want 10 by 3, to make these two values 10 by 3, first I want one column where the value 10 should be there. Then another column where the value 3 is there. Both the columns, I want values separately. Then only I can take 10 by 3. See here, how I can take the count of male by female, which is in the same column. See, to take the fraction like one value by divided by second value, we want two columns. One column separately for females, one column separately for males. Are you getting me? See, for getting the pattern of M by F, like this. First, we want two columns. One column for separately for male count, one column separately for female count. Are you getting me? But here in our table, we have male and female values separately. Separate is there or all are combined together? Column only. One column only is their count. Count is single column only, not separately. But here we want separate values. Male separate, female separate. So what to do? What to do? How to convert the separate values, male and female? We are using proc transpose. What we are using here? Proc transpose, where the values count, right, which is present here in the form of a column. We are actually one column we are converting into separate, right? And finally we are grouping the value by group, because this value should be grouped by separately by separate groups, right or wrong? The value should be separated by groups. Every value should be separated by groups. Not only just m by f we want m by f also, and we want separate value for each group. Separate value for each group. Understood? So we mentioned by group and ID as a sex. So this why we are doing means to reshape the data, right? To get the separate count for the variables. Which variable? Grouping by sex. See the separate count, ID by sex, right? Sex wise it will divide the values. The count values will be divided, right? Or separated by sex and group. Understood? Let us see how it looks like. You will see, you will understand the answer. After running the program only, you will understand what I am telling here, right? Just I am running the program. Okay. See here, we got the count now. See, count we got now separately as per the group. Separately by group. Understood? For example, this group separate count is there, right? This group separate count and this group separate count. Everyone getting me? Group wise count we got. We got the values group wise. Everyone understanding or not? See, group wise we got the count. And one more thing, we may mention ID. So what the ID will do? ID will divide the value into separate columns. See, in the ID sex. Sex means what? How many types are there in the sex? The sex column. How many types are there? One is male.
2.
Other is female. It will divide the sex into two columns. ID will divide the sex into two columns. One is male column, other is female column. Can you see here, everyone? Male column, female column separately. So we got
Yes,
now two columns separately. Female column separately, male column separately. And also the values are grouped by what? Groups. Group by groups. Means the GF value, separate values are there, 3 and 18, right? Separate value for the GF. Similarly, for the second GF M50, we have the separate value, the second row. You can see this is the GF M50. Similarly, the GF M plus M50, separate value. So the values are separated by group. So two functions, two benefit we got. What are the two benefit? First of all, the count are separated, male and female in separate columns, right or wrong? Male and female separate columns, and the values are grouped by different groups separately. Before actually the values are in the same group. All are actually clubbed to the same, right? Now it is separated. Everyone clear now? What we done? We reshape the data here. So this programming part is very important. Here the points you have to understand. Where means it is transposing the where count, right? First of all, and grouping the value by group, right? Grouping the values by group. For separate group, separate count is generated, and ID sex means dividing the sex values into separate columns. Understood, everyone? This proc transpose, everyone. First of all, it is taking the count variable, grouping the count variable in the three groups. What are the three groups here? GF group and GM50 group and GF plus M50 group. Three groups it is displaying separately values. Now the third point is what here? ID. ID will divide the values into sex separately, male and female. Everyone clear? Okay. So see here. So what we have done, this part is over. Now, but still if you see the result, is it matching what we required? Still, is it matching? It is not matching.
No.
It's not matching. We got the answer somewhere near, but still it is not matching what we want. It's not matching. So further programming is incomplete, I mean to say. What we want to do here again, see, we want to take m by f value. What we want here? M by f value. Right or wrong? In the program, what we want now here? We want m by f. M by f. We want to club the values together. If for joining the values by m by f, which function will join the two values? Anyone? See, we can use the combel also or concatenation pipes. What is the function of cat function and concatenation pipes? It will merge, it will join the values. It will join the two values. Understood? Cat function also will do the same work, and concatenation pipe. What is the concatenation pipe? These two lines. Can you see these two lines? Parallel lines, everyone? These two lines are the concatenation pipes. Just refer the notes in the SAS, in the functions. I have told you this point. Just go refer the notes, right? So two parallel lines, what it will do? It will join the two values. See, for example, how we want to join here? I want the first value to be what? First value is the male. In between, what we want here? Between the male and female is separated by slash, forward slash. So male, forward slash, female. These are joined by using what? Concatenation pipes. By using concatenation pipe. One more thing, why we are using the combel function? Combel function will remove the spaces. What it will do? It will remove the spaces. Compress, combel. You remember or forget everything? Compress, combel, what it will do? It will remove the spaces. See, after joining the values, we are storing in a new variable called, what's the name of the variable? Gen. Gen is the name of the variable. Let us see the result. What happens here? Can you see everyone here? The result is there in the output data here, right? So you can see the result here, DM4. Can you see the values are joined? 18 by 3, 18 by 1, 15 by 4. Now they are joined. So now it is little bit, it is resembling this format, right? But still, this is not resembling entirely. Why? Because here all the gender values are present in a how many rows? How many rows? Single one. Here, how many rows are there totally?
3 rows.
3 rows. Are they matching still?
No.
Not matching. Still, it is not matching. So what we have to do? See here the multiple rows into columns. Again, which procedure convert the rows to column, column to rows? Again, we have to use the proc transpose. In the proc transpose, these multiple rows of gender, I want to convert into, see the gender column, I want to convert into rows. See, column to rows or rows to column, we have to use the proc transpose. So here the proc transpose I am using. On which column I am using here? Gender column. See, gender column is present. I want to convert into single row. Understood? The column is having multiple values here, converting into single value here, or converting the column into rows. See, now if you see, one second, right? Now, for example, if you see here, it is present in the form of gender is present in the form of column, no? Gender is present in the form of column. Gender is a column or not? GEN is a column. I want to convert this column into row. I want to bring it here, where I want to bring the gender here in the column side or row side? Row side.
Rows.
So converting the column to row is a proc transpose, where we are mentioning the where gen, converting the gender into from column to row. First point, clear? Second point, ID by group means, see, I want to separate the values. See, here we have what? The values are separate in the form of group. Values are separate in the form of group. Three groups are there, right or wrong? See, the group values are in the form of what here? Column or not? First column of the group, second column of the group, and third column of the group. How many columns are there for the group? 3 columns. Are you getting me? See, the values are separated by groups. We want the 3 columns of the group separately. So again, I told you which value converts, which actually the keyword convert the single group value into separate column. Just now we use that term. What is that one? ID. What the ID will do? ID will split the one column into separate. We have done the male and female. Do you remember just now? It separated the male and female into separate columns. Since we have done, we converted the sex values male and female into separate columns by using ID. Here also we want the group column. Group column is how many here? Single group column is there. I want to separate into how many groups? 3 groups. So which statement convert this one? The statement ID. ID will do what here? Convert into separate groups. So now I am running this program, right? This programming part I am running here. Okay. Now we got it here. Now little bit it is resembling this one. Understood? See, we got 1 row only. Right or wrong? How many rows here now? 1 row for the gender. Same like here. And the values are what here? In which format? M by F. Right or wrong? By 3 groups.
Group.
One group is GF, GF M50, GM50. Now it is resembling little bit, right? Not 100%. It is resembling little bit. So till now, what we have done in the programming? Only we have derived the first row. We just derived the first row from here to here. For deriving the first row from here to here, this much programming we have done.